What is the first law of thermodynamics, also known as the law of energy conservation? This law is one of the fundamental principles in physics that explains how energy behaves within a system. At its core, it states that energy cannot be created or destroyed, only transferred or transformed from one form to another. The idea is true that anything that uses energy is a key part of both classical and modern physics.
Mathematically, the first law of thermodynamics can be written as delta U equals Q minus W. Delta U refers to the total energy contained within a system, which includes both kinetic and potential energy of the particles due to the interactions between them. Q is the heat which flows from a hotter object, to one that is colder. Let's say you're given a system that is 20 degrees Celsius and the surrounding is 24 degrees Celsius. Q, which is the heat, would flow from the surrounding to the system. This is due to equilibrium. Work is the energy transferred when a force is applied over a distance. Let's say you're given a system and work is done by the system to the surrounding. Then delta U will decrease. Let's say you have another system and work is done to the system, delta U will increase.
If we are given a gas piston and we add heat into the gas piston, the molecules will start to move faster. This would therefore increase the internal energy of the system. If the piston pushes outwards and does work on the surrounding, this would decrease the total internal energy of the system. Energy can flow into or out of the system by two ways, heat and work. If heat flows into the system, and if the surrounding does work on the system, then the overall system gains internal energy. Here's an example where we're given a system and a surrounding. If we add 300 joules of heat into the system, and we do 200 joules of work on a system, and we follow our equation stated before, delta U equals Q minus W, then delta U would equal to 300 joules minus negative 200 joules. The 200 joules is negative here because work is done on the system. This would give us a total internal energy increase of 500 joules. This didn't come out of nowhere. This means that the surrounding has lost 500 joules of internal energy. This is because, as we stated before, energy cannot be created nor destroyed. It can only be transformed from one form to another.
There can be three kinds of systems to take into account: an open system, a closed system, and an isolated system. In an open system, matter can flow in and out, and so can energy. An example of this can be a boiling pot of water where heat enters and steam escapes. In a closed system, only energy can flow in and out of the system. An example of this could be a gas in a piston where heat is added or removed. In an isolated system, there is nothing that could go in and out, and there is no energy exchange with the surrounding. This means that delta U is equal to 0 and energy remains constant.
There are some key thermodynamic processes where this law applies in unique ways. There is the isothermal process. Since temperature stays the same, there is no change in internal energy. Therefore, any heat added is completely converted into work. There's the adiabatic process, where there is no heat exchange. Delta Q equal to 0, so all energy change is from work. There's the isochoric process, where the volume doesn't change, therefore no work is done, so all the heat goes into changing internal energy, therefore delta U equals Q. And there's the isobaric process. Pressure stays constant while heat and work interact, therefore delta U equals Q minus work.
In summary, the first law of thermodynamics is one of the most fundamental principles in physics. It governs energy flow in engines, power plants, refrigerators, and even our own bodies. By understanding this law, we can develop more efficient energy systems and better understand the world around us.